Welcome to the Food Packaging Forum's webinar on food packaging and the circular economy. We're very pleased to welcome all attendees that are joining us today. And just for your information, we're recording this meeting and we'll make it available on our website for future reference. Also, just for your information, unfortunately, we can only admit a limited number of participants to our webinars. So in case you sign up for a webinar and you know in advance that you won't be able to make it, just please kindly let us know so we can give your spot to someone else. Thanks. Today we're going to be talking about food packaging in the circular economy. And we have one speaker who is Dr. Birgit Goelke from the Food Packaging Forum's team. I'll introduce her in a minute. I would just like to take this opportunity to share some information about Food Packaging Forum. We're a charitable foundation established 6 years ago in Zurich in Switzerland. We focus on science communication about chemicals and all kinds of food contact materials and articles. And we're interested in the migration into food and the impacts that these chemicals have on health. We focus on the current science, and we also take an interdisciplinary perspective. We offer a free newsletter and dossiers, webinars, annual workshop, peer-reviewed articles, and so on. And yeah, I would like to also point out that we're funded by donations. So if you think that our work has value, then I would like to invite you to visit our website and consider making a donation. Great. And so this is the agenda for today's meeting. We're going to hear the talk by Dr. Birgit Goelke on circular economy, how to safely reduce, reuse, and recycle food packaging. And afterwards, we will have time to ask questions. All participants are invited to participate in the discussion. You can also contribute with comments and so on. If you do have questions or would like to contribute with a comment, then please send us an email to events@fpforum.org. Okay, and with that, I would like to introduce our speaker for today. Dr. Birgit Goelke has been part of the Food Packaging Forum's team for 5 years now, or over 5 years. She has a background in environmental microbiology, and she worked for many years in academia. And now, for the last 5 years, she's been focusing on chemicals and food contact materials and articles. So, welcome, Birgit, and thank you for doing this.
Welcome you to our webinar today on the circular economy. And the title of the webinar is How to Safely Reduce, Reuse, and Recycle Food Packaging. Let me start with a slide on the circular economy first. So all of you have probably seen several of the illustrations producing the circular economy. On the left side, you have an illustration which was published by the European Environment Agency, just illustrating the main principles. I won't go into detail here because I think you're familiar with it. And on the other side, you find the aims of the circular economy as it was defined by the European Commission. So two of the main aims are that within a circular economy, we would like to maintain the values of products and materials and at the same time minimize waste and resource use. To achieve these aims, there are several areas of action. So first, one could start with product design, which is quite important. Then the production process can be involved. Consumption, how we consume and how we handle our waste are other areas of action which help to support the circular economy. However, there are different sectors and materials which face specific challenges. And in our opinion, food packaging belongs to these materials or to one group of these materials facing specific challenges. That's why we have started to work on this topic. So just last month, at the end of May, there was a new directive published by the European Commission, and it was voted by the Parliament and the Council of Europe, and their new recycling targets have been set. So you see them in the table here. They are 65% of packaging waste shall be recycled by the year 2025, and this number should be increased to 70% by the year 2030. So you see in the year 2013, the targets of the year 2025 have already been achieved, so it seems to be quite good as it is done in the European Union. But if you look at the single materials below, you see that there are quite some differences. And if you would split these numbers into different countries, then the differences would also be quite more visible. So for some materials, it seems to be fine. So for glass, paper, and cardboard and wood, the targets have been reached. For the metals, they are already quite high. I don't have the separate numbers here. And for plastic, there you see that's the material which has the biggest gap to the targets which have been defined or concluded on recently. So there is some work to be done to reach the requirements, the legal requirements, and additionally, we have to mention that these are only the quantitative targets. I'm sorry. So they don't define what is happening with a recycled product. I think that's also very important to mention. Coming back to food packaging and the circular economy, as it was said, we would like to maintain the value of products and materials, and we would also like to minimize waste and resource use. To reach these aims, one could start with a redesign of packaging or of materials used to package our food, but also other measures are important, such as reduction, reuse, and recycling. Depending on what actions are chosen, there are different challenges popping up. For example, the energy use has to be considered. Waste management is always very crucial. Food waste is important. If you look at food packaging, you always have the connection to food waste. Then the safety of the food, and the consumer has to help with all these measures. So the consumer has to accept and support anything which is chosen. Now I would like to introduce some examples for reduction, reuse, and recycling. And I start with a reduction of food packaging. You see very different pictures here, and it already shows that reduction is not a very simple principle because you can do it in many different ways. If you look at the first picture, you see that there is hardly any food packaging. That's could be or was taken in a zero waste shop, where you bring your food packaging and you really try to avoid it as much as possible. Then the second picture in the middle is our PET bottles, and there the reduction is completely different. So PET has been reduced by making it lighter. So you can use less material and fill the same amount of water or beverages inside. And then the third example is again something else. So there only one part of the packaging has been reduced. So in this case, this ham packaging uses 60% less paper and plastic packaging, and this plastic packaging has been replaced by paper packaging. So that's also kind of reduction. And depending on which way one chooses, there are different challenges. So the waste has to be managed. The food waste could be increased. For example, if you go to zero waste shop, you could say, okay, but it's spoiling more easily. But on the other hand, people may only buy what they really need, so they don't have to buy big packages and just buy a small portion, so they can decide how much they want. Safety may be an issue for multi-layer packaging because you may have more different chemicals inside, so the example on the right. Safety may also be an issue if you have loose food, because it's not so separated from any bacteria which may fly around. And for all these examples, the consumer have to support them. So maybe people don't like the very thin PET bottles because they are too thin if you open them, so they get squeezed. Or, of course, one has to be prepared when going to a zero waste shop. Now coming to reuse, that's more limited in comparison to the reduction principle, because not all materials can be reused. So in this case, it's only possible for glass or certain types of plastic or metal, and paper and board, of course, could also be reused, but only for very limited cycles. So here the challenges are also the energy use, especially if you go to a classical deposit system, which has been known in some European countries during the last decades. There you usually have long transport distances, and it may take a lot of energy if you transport empty glass bottles, which run under a refund system if you have to transport them for a long distance. Again, the consumer have to support any reuse. Also, these other two examples, if you try to avoid single-use coffee cups and introduce maybe by the city a system for reusable coffee cups, which can be returned at many places, consumers have to carry the dirty coffee cup for a while. Or also takeaway restaurants may use reusable containers, and there they have to get the support by the consumer. So here, energy and consumer acceptance would be the two major challenges. Now coming to recycling. This has been, I would call it, the hottest topic during the last years. And although it's not on top of the waste management hierarchy, a lot of effort has been undertaken to improve recycling of food packaging. However, as I mentioned previously, recycling should not only be considered looking at the numbers, but also at the quality. So I can say I've recycled 80% of my material, but if I cannot use the material for the same purpose again, it's maybe not the same. So here I have found a rather strict definition of recycling, and it says that conversion of the used product back to raw material allows repeated making of the same product over and over again. And then recycled material should provide the same quality of the product, and the properties should stay the same. And a third point, which is also important for the Food Packaging Forum and will be a focus of the second part of the talk. So no contaminants or toxins shall accumulate in the food packaging or in the recycled material after multiple recycling loops, because otherwise the secondary product would be less safe. Here are also some examples of recycling, and there we first have to look at the materials. So one can separate food packaging materials into two different groups, the permanent materials and the non-permanent materials. And for the permanent materials, here are the examples, glass and metal. That means they usually don't change their properties after recycling or during recycling. So if I have a glass bottle, in the beginning I can make a glass bottle with almost the same properties after recycling, after remelting. And the same is valid for many metals. Maybe also not absolutely, but you can do recycling of glass and metal many, many times. In contrast, the non-permanent materials, they usually change their properties during recycling. So they lose the physical chemical properties, and usually virgin materials has to be added to keep the quality high. And here are the examples. It's plastic, it's paper and board, it's multi-material, multi-layers. Typical materials used in food packaging. The challenges here are, again, the waste management and the consumer acceptance, because the consumer has to separate the waste somehow, and then it has to be managed anyway. It has to be rather clean, especially the non-permanent materials like to attach some dirt more easily. So that is a challenge here. And then the safety after recycling is another challenge for all materials, but also more for the non-permanent materials, because during recycling contaminations are easily introduced, more easily than during production of virgin materials or fresh materials. Anyway, there are already many interesting initiatives trying to support the circular economy, and here I've just listed some of them, showing that you can go in many different directions. And the first, you find more information and also always new information on our website, so these are just some examples. Let me start with a redesign. So in December 2017, Marks & Spencer announced that they are planning to use only one recyclable plastic polymer for all plastic packaging. That would make waste management, of course, a lot easier, but it will certainly introduce new challenges. Then Nestle announced that all the packaging they are using should be recyclable or reusable by the year 2025. That is, of course, also strongly supporting the circular economy. And the Plastics Recyclers Europe initiated a platform to assess plastic materials and their recyclability. That's concerning the redesign. Looking at reformulation, there you don't change the whole material, but you try to avoid certain chemicals. And that's, of course, when you look at toxic chemicals, it's also very important to avoid them, because in a circular economy, they would circulate all the time. So in this case, retailers and brand owners, several different companies have started or have published chemicals policies to decrease the levels of chemicals of concern in their products. And one example that was the topic of our last webinar is the food packaging product stewardship considerations. So this is a list of chemicals which should not be used by certain brand owners to pack their products. And then the third example I have here, the complete reduction of packaging materials could be done in zero waste shops. Now I come to the second part of the talk. It's more about the contaminations and the hazard of recycled materials. So first I've shown you the different ways or the different actions you can choose, but if you decide to go for recycling, or if one wants to go for recycling, one has to make sure that the food packaging in the end should be safe. And we have recently published a paper on food packaging in the circular economy, where we focus on recycling and focus on contaminants which are commonly found in recycled food packaging materials. So I will shortly list some of the main points for the 5 different materials we have discussed in the paper. So I start with plastics. Here I only focus on mechanical recycling processes, but because these are the ones which are mostly used. And under European legislation, all plastics which is going to be recycled and going to be used for food packaging again must fulfill the requirements for virgin plastic food contact materials. So that's under European law, and any process used to or applied to recycled food packaging needs to be assessed by EFSA and authorized by the European Commission. So this, yeah. And in the US, it's slightly different. There it's more like a recommendation. So the US FDA issues favorable opinions if one submits the recycling process, but it's not a legal requirement. And looking at the recycling processes in the EU and in the US, which have been evaluated by EFSA or the FDA, you see that the vast majority of processes is for PET. And then there are a few processes for polyolefins in the EU, the blue bars, and in the US, the red bars. But they, especially in the EU, they already have quite some restrictions. So recycled polyolefins can only be used for certain purposes. Then you have other recycling processes for polystyrene and other materials in the US, but none in the EU. There are quite some challenges if you look at plastic recycling. So it's based on the physical chemical properties of the materials. So plastic does change. As I said, it's a non-permanent material, and you have to melt it somehow to get the new plastic, and then usually the polymer breaks down and other changes happen in the material. Then another challenge is that different polymers are not compatible, so they have to be really well separated to guarantee a good recycling process. If you have products composed of or consisting of multi-layer plastics, then you cannot recycle them at the moment into new food packaging, maybe into something with a very decreased function, but this cannot be done at the moment because you would have to separate the thin multi-layers. And here are some examples. As I said, PET is easily or well recycled, often recycled. That's because it usually doesn't absorb so many chemicals and it's easy to separate. So again, the waste management plays a role. Mainly PET bottles are recycled and they are easy to collect. They're usually quite clean. And together with the properties of PET, that allows quite efficient recycling of PET bottles. Coming to the next material, polypropylene, you already see that's more difficult because of the properties. It absorbs more chemicals. Polypropylene packaging is usually used for other purposes, so it's often not as clean. And then you find the transparent or the black versions, and unless you don't want to have black, in the end you would have to separate these, which is also quite a challenge during waste management. Here I list some typical contaminants which have been found in recycled plastics, and I've grouped them. So the first group of contaminants are the additives and the degradation products. If plastics are recycled, then they usually already have some additives, and some of them, like antioxidants or UV stabilizers, they react during use. So they change their molecular structure. So you have even more contaminants and maybe not known contaminants in the plastic, which goes into the recycling, and you don't know them. But they stay. Maybe some of them get removed, but some of them stay. And the degradation of these additives is intended, but nobody really cares so much about what is happening with them. If you give it into the recycling, and you, of course, during recycling, you have to add new additives which are fresh and fulfill their function in the second round. Then something else, that's if a company wants to do it correctly, then it's not a problem, but obviously it has been a problem because there are quite several publications on contaminants from non-food grade plastics in plastic packaging. So somehow the waste management was not okay, and there are examples that brominated flame retardants have been found in the lids of coffee cups and in other mainly black plastic packaging, and they originate from waste electric and electronic equipment, and that's of course not food grade and shouldn't be there, but it happens, so that's a challenge and one has to take care of that, of course. And then typical other contaminants which are frequently found are flavor, aroma and odor compounds, oligomers, monomers and derivatives of these molecules. Especially this second last group, these types of molecules are also found in virgin plastics, but they may change during and after recycling. The composition of these contaminants may change. And then last but not least, inorganic elements are also found in recycled plastics. Coming to paper and board, the second non-permanent material which I introduced. There are established recycling systems in many countries, so recycling of paper and board is going quite well. However, there's no sorting into food grade and non-food grade materials. And there are many chemicals used in printed paper and board. So we don't know the exact number, we just have inventories but there are many. The physical chemical properties of these materials are also not ideal if you look at chemical migration, because paper and board has low barrier properties and it promotes migration from the maybe printed surface or also through the material itself. And additionally, paper and board easily absorbs contaminants. Here is a list of typical contaminants, and all of you interested in recycling of paper and board have seen them, I'm sure about that. And some of them have been seen by everybody, I guess, like mineral oil hydrocarbons have been found frequently in almost all samples of paper and board, recycled paper and board. Bisphenols, they come from thermal paper receipts if they enter the recycling stream, or also ink and glue formulations. Phthalates, diisopropyl naphthalenes, they originate from carbonless copy paper, so office waste, paper waste would introduce these chemicals. Photoinitiators come from UV cured printing inks, inorganic elements also, and then there are quite many others. And if you refer to our paper, you will find some good overview articles cited which list all of these typical contaminants in detail. So here the possible measures are quite strict. So one has to reduce the contact of recycled paper and board with the food. I think that's the basic of all the measures. So either the contact with food is restricted completely, as it has been done in Switzerland. So there is a law prohibiting contact of recycled paper and board in contact with food. Or one introduces functional barriers like internal bags or barrier layers on the surface of the packaging, or adsorbents in the packaging. And all these measures increase the safety, of course, but coming back to the circular economy, one needs to ask whether these are in line with the goals of the circular economy. Then coming to the multi-layer multi-materials, that is a difficult word, but examples are more easy to understand: beverage cartons and laminated films, so any pouches, for example. And they are composed of paperboard, plastics, and or aluminum, depending on the type of packaging. And here only the fiber, the paper fraction, can be recycled at the moment, but the products, again, are not used in direct contact with food. That's similar then looking at paper and board packaging. Then the last group of food packaging materials, glass and metals. These are permanent materials, and one of the main differences are that the organic contaminants are destroyed during recycling because of the heat. When you remelt metal or glass, no contaminant survives, no organic contaminant survives. Then collection and separation have major impact on recycling performance, but also here, as for paper and board, very established systems exist in many countries. However, in glass, the lead content can increase with repeated recycling. And for metal, it's another story, because most metal food packaging is freshly coated after recycling. So that means that even if the metal composition changes slightly or different alloys are recycled together, the coating is the main issue if you look at migration and safety issues, and less the metal if you look at recycled metal food packaging. However, chemical safety of recycled metal and glass packaging needs to be managed, or at least, like, for example, in glass, monitored or taken care of. Now I would like to conclude. So I think it's common knowledge that food packaging at the moment strongly contributes to global waste issues. In addition, food packaging is a relevant source of chemical exposures. And to solve the first problem, the global waste issues, one has to keep it circular. So reduction, reuse, recycling, and redesigns are tools to decrease the environmental impact of food packaging. But especially when looking at recycling, one shouldn't forget the safety. So recycling of food packaging increases the risk of chemical contamination, and especially in the case of non-permanent materials. So the current focus on recycling needs to consider chemical safety issues if one really wants to recycle food packaging into new food packaging. With that, I would like to finish the talk, but just would like to invite you to our workshop in October. So on the 4th of October, we will hold our next FPF workshop on predicting the safety of food contact articles, new science and digital opportunities, and you're most welcome to register. So online register, and welcome to Zurich. And with that, I would like to thank you and answer your questions now or later if you contact me.
Great, Birgit. Thank you very much.
Thank you, Jane.
For that very compact, informative talk. So I am going to check if we've got any questions. Okay, so just to get our discussion started, from your assessment now, after comparing these different recycling processes and looking at these different kinds of food packaging materials, where, in your opinion, are the largest knowledge gaps in terms of our ability to assess the chemical safety of these materials? It's a difficult question, I'm sorry.
No, that's fine. So I think the knowledge gaps are starting to decrease. So there is a lot of work going on. However, I think all the non-PET plastic packaging, I think there are a lot of knowledge gaps, because even for such a common material as polyolefins, there is not really too much known how to recycle this material safely into new food packaging and which processes to use. And I think if one aims for the recycling of all plastic packaging, one has to do quite a bit of work. For PET, I think a lot of knowledge is already there, but for other plastics, much has to be done. And talking about paper and board, I think also there a lot of knowledge is available, but there the problems are just quite big if you try to reuse recycled materials. So maybe there, even if you fill the knowledge gaps and know what you have in the recycled materials, in the end you don't have the solution to the problem.
So more research needed in many areas. Okay, so another question is, you've discussed chemical contaminants. What about biological contamination, mycotoxins, and also pathogens? Maybe did you look into that?
No, not in this in the scope of the publication or the project. And so the mycotoxins is the question referring to the food or to the food packaging. So that recycled material may not be as stable as the virgin material, or that the food is not as protected.
No, in recycled plastic.
In recycled, okay. Yeah. No, we haven't looked at that, and if there is anything available, I would be happy to receive a reference.
Could be interesting, yeah, exactly. So you made this distinction between the permanent and the non-permanent materials, and if we look at the goals of the circular economy, one of the goals is to keep the value of materials that are circulating in the circular economy quite high, which obviously kind of looks like a good opportunity for the permanent materials, where we do need a lot of energy to make them, but they're also more inert and hence can be recycled more easily. But I think there also is a role for the non-permanent materials in the circular economy. Do you have any thoughts on that? How do you think the non-permanent materials can position themselves if chemical safety is ensured?
It's good that you ask that, because for sure it's not that you have or can conclude based on this short presentation that the non-permanent materials shouldn't be used. I hope that I can that I haven't shown it like this. Yeah, I think they can also be a sustainable solution if you would go for renewable sources, considering all the other aspects. That's, I think, the major challenge again. It's not only the safety, it's also the energy, the resources in the end, if you look for something sustainable. And in the end, you have to evaluate all the factors. So as you said, assuring that it is safe. It's one requirement, but of course it shouldn't use too much energy and it shouldn't use too many resources. So all of them have to be evaluated with looking at all the factors in the end.
But, I was thinking of maybe a concrete example, like for example, biodegradable food packaging for takeaway food, for example, tea bags or, something like that, where you will have a mix of food waste, avoidable or not avoidable food waste, and packaging. And that could, for example, be an application where you then can compost your packaging together with the food waste. That could be an example. Okay, good. Well, I think with that, I would like to end the webinar, and you've made it easy for me, Birgit, because now I don't have to pitch our workshop again, but I'll just say it again, just in case someone missed it. October 4th, we're holding our food packaging forum workshop here in Zurich, and it's open to anyone who would like to participate. You can also participate over the web stream, so if you can't travel to Zurich, make sure that you register for the web stream. And please also send us feedback on our work, on the webinars, but also on other parts of our work, like the dossiers, for example, or the news. And we're also always happy to take suggestions for topics that you would like us to work on. For example, the mycotoxins. I think that would be an interesting issue to work on. Thank you very much for joining us today, and have a great day. Take care. Bye. Thank you.